So everybody, with the pizza, with the beers, I'll try to be not boring. No promises. Do you know what that means? Who knows what it is?
Batman.
Good. Who knows what it is? Good. What is the famous line that is happening in this part of the movie? Who knows? Or what is the most famous line that happens in the Star Wars saga?
I'm your father. No?
What did you
Say it
say?
again, say it out loud.
No.
Please?
I'm your father? No, not that one?
Yes.
That
So the one that everybody remember is Luke, I'm your father.
Oh, yeah, okay.
Right. Which is not real. That's not the line. The actual line is no, I'm your father.
Oh, no.
This is one. Fun fact about memory. Do you know here how long the memory of the fish is?
30 seconds.
Good. Anyone has better guesses? 7 seconds. Who else? 3 seconds. Good. How many glasses of water we should drink?
8.
Very good. All of this is not true. So this is what we all know. This is not true. So we hallucinating all the time and we're lying about facts all the time. The humans are imperfect, exactly as they are. We're all fired. We're all hallucinating. I don't know. I assume some of you go production at least once. Let me tell you my story. I started 20 years ago as sysadmin. I installed my Linux laptop for the first time. I was very happy. At the end of the day, I'm proudly doing shutdown usage now in the terminal. I'm hitting enter. I'm proud. The terminal is shutting down. It's closed, but my laptop is still like working. I shut down something. This something was a production cluster of billing of a mobile operator. It wasn't pretty, and I learned a lot from this. But this was my mistake, since then, I learned how to not to do those things. And I actually became a AWS community builder, and today I'm a CTO at TeraSky. We're a global solution integrator with projects around DevOps and AI. I'm HashiCorp ambassador, a platform engineering ambassador as well. And I was consulting with a company called HubSpot, and they have like this very, very awesome practice. Every time someone will break anything, they will do two things. First, they will bake a cake, and they will put a name of the component that they brought. So there will be like cakes of Kafka and cakes of Aerospike, and it was very pretty and emotional. But they also would like create an automation to prevent this thing from happening the next time, which is like a good engineering practice, and embracing the failure, which is nice. So I know I made a mistake. You're probably perfect, you don't do mistakes. Tell me if you can see, and if you can tell within 10 seconds, I will give you 10 seconds, if this Terraform code will work. Starting now. Okay. Who thinks it will work? Okay. Who
No.
thinks it will not work? Who is not listening? And who, by the way, here knows what is Terraform? Good. And how many of you are platform engineers, DevOps, or SRE? And harness engineers? Is that a job already? Not yet. Cool. So this will not work, but it's very hard to say if it will not work. But the reason it will not work, there are two reasons. One, there's like an attribute missing inside of AWS instance. It should provide at least subnet or VPC, otherwise it will not work. But also, if I would have this attribute, it will not always work. Because sometimes, for example, I have a reference for init.sh, it will not be present. So kind of tricky to know if it will work. But this is not fair, right? This is the code that you didn't write, so it's like, you can't really say if it will work or not. How about looking at the code that you write yourself, but you don't remember? So you're like reviewing something, and you're like, what does this thing doing? And who is the idiot that wrote this thing? And then you're doing git blame, and it's you. And you have no recollection why you wrote it like this, or like, what does it do? It's like, it's like reading a letter to your future self 10 years after you wrote it, like, who was the person? Why did I do that? So there's a very good book. It's like popular science that you're not as smart as you think. But basically, all of those kind of failures, all those cognitive biases, they're very interesting. So, for example, how do we hallucinate, or the Mandela effect? How does this happen? We have an assumption that in our brain, the memory is like an awesome, very deterministic and specific video recording, which is not what's happening. What is actually happening is that memory every time reconstructed, and we kind of rebuild it every time, and then we feel that we remember. Very awesome experiments that are actually happening is that I maybe remember something, and then someone tells me a story about the situation, and he introduces a new thing that I didn't remember. But the next time I will talk about it, there's a very high chance I will see this vision with this new detail as if I actually experienced this, which I never actually remembered in the first place. And this is very similar to kind of how LLM generates the next token and picks it up, and we're just reconstructing it every time. So this is kind of why we are hallucinating. We don't remember facts, right? Or like we're not sure about how did we get the origin of this fact. This 8 glasses of water, we just heard it enough times from someone who is relatively authoritative, so it became true. It's exactly the same thing if I write something 100 times in my prompt, or something that appeared enough times during the training, so now it's true, and the origin of these truths are questionable. We can't always say if the code will work, but what we'll do to make sure that it's working, we will actually try it, and then we will know if it's working, right? And, you know, we broke production. I assume most of the people, or most of the people here broke production. Maybe we cannot do it like Jenny in 9 seconds, delete all production and all backups. That's kind of tricky, but we can break it pretty well.
Fuck it OS.
Huh?
Fuck it OS.
Yeah. So, the double standard, right? No one here feels like there's something wrong with him because he's hallucinating, he doesn't remember facts, he's breaking the production. We build entire civilization on top of this, like imperfect humans communicating with each other, building amazing stuff, and it's working. When AI does this, we automatically think it's not great. By the way, TeraSky hiring broken humans, so if someone here is looking for a job, please talk to me. So what do? One, we understand that AI is not perfect, and that's okay. 2, I think that's kind of a tricky one. And I assume most of the people in this room are probably not like this, but I'm sure most of you know a person that would look at something that was generated by AI and say, this is not perfect, we cannot allow it to be in production or to use it or whatever. And there's a certain group of people in a lot of organizations that expect this one-shot perfect outcome, and if it's not, the organization is like unable to adopt AI, which I think slows a lot of organizations down, and it will definitely make them into the blockbusters of tomorrow, while the Netflix is eating their business. And we want to just have a better results, right? So we're in this evolution. When we started with, you know, opening cursor, writing something, having auto-completion, doing tab, 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 we moved into like the second phase where now we're describing something in a prompt of, I don't know, Cloud Code or cursor. This is the function that I want, make it like this, test it like that. We click enter, and then kind of we define it, what do we want, and we generate it. And now we're going into this kind of citizen developer, or more like of a base 44 experience when I say, I want this. And then something will make actually a very good code out of that thing. So how do we do it? We want to define the goal, we want to define the workflow in which we work, for example, write tests and write code and do validations. We want to say those things beside my general recommendation, make it secure. Here are some of the things that I want explicitly to know that are working exactly as I want them to work. And then I know that I will have to let AI run over and over until he figures that part out. And eventually, I will probably have to do some iteration on like whether my definition of the workflow was good, whether my definition of what's important were good, and did this whole thing work. Now, all this thing kind of becomes This is, by the way, how Aspire were working in terms of like improving their stuff. And this is the harness engineering story, basically, right? Who is here familiar with Michio Hashimoto? The Terraform creator and HashiCorp founder, CTO. This guy created Terraform, but this guy I think also considered to be the one who coined the harness engineering term itself. This thing happened in February this year, and suddenly everybody now, by July, is harness engineers. And he kind of described his own workflow. This is the blog post that he coined this term. He was saying like, I'm working with AI, by the way. He also building a very great terminal called Ghosty, you should try it. And he was saying like, when I work with Gen AI, this is, or with AI automation, this is how I work, this is how I guide it not to do the mistakes and exactly to get what I want. And this is kind of engineering my harness. And there's a level, right, to the harness. There's like the cloud code, which by itself is a harness, but then there's my own layer on top of it of what I need as my specific organization. Then, very quickly after that, OpenAI came with this post. Who wrote this? Who read this post? You know this? So first of all, I suggest you read it. It's actually pretty interesting. There's a group of like 5 OpenAI engineers that shipped a code to production within 6 months by building like a harness and leveraging codecs in it. And this code was like 1 million lines. Now, kind of, I don't know, it sounds suspicious, 1 million lines within 6 months. Probably some of it was token maxing and weird stuff. But again, they were able to do it. They were able to do it with this harness, and they were able to ship it to production. And actually, they talk a lot about how they manage this harness and how do they do it. So what is harness? This is kind of how it's being explained. I kind of like it the other way around. Everything in my agent that is not a model, it's a harness, right? So the way I handle the loop, my MCPs, my tools, everything that I need for my agent to be able to function properly is a harness. What will I do in a demo? I will show you quickly kind of the result, but because it takes about 20 minutes for the full execution. But by the way, are you familiar with this language of Gen Z when they say no because sane? No, I'm the only one. This is very convenient. It took me a lot of time to actually understand what it means. Yeah, as a boomer, it took me a while to process it. But no, because Terraform, because Mitchell also created Terraform, so I thought it's kind of awesome to show this example on top of this, and it's so close to me as a DevOps. And this is kind of the goal that I'm giving it. I'm saying, take the Spring pet cleaning image and deploy it to AWS and make sure it's reachable over HTTP. That's kind of my goal. I'm not explaining anything beyond this thing. And then I built it on top of Cloud Agent SDK. Well, I will have to rebuild it soon because they're taking the tokens away from me. But basically, it can be built on top of anything, right? It can be definitely built on top of just Cloud Code. It doesn't have to be like that. And validations that are important. Those are my sensor of how I want to make sure that it's actually working. So another thing by Mitchell is those terminal. And this is kind of the execution, right? I'm saying Python harness, this is my goal. Deploy, Spring, pet cleaning, this is the image, and just deploy it to AWS. That's what I'm saying. I will show you in a second the code, but basically what I'm doing here is I'm saying, create this Terraform file, Terraform code for me. But I'm saying that I want this thing to be secured. But the problem, do you know what the problem with telling an agent make something secured or make something production ready or make something not break? What's the problem with this? Anyone?
It doesn't work.
It prevents it from being accessed by the internet?
Well, first of all, it's a very good question. Maybe it doesn't have an access to the internet. In my specific case, it doesn't. Yeah. Right. Of course, it should be HTTPS. I can be an idiot and provide stupid goals, but this is just an example. You're right. But in general, I think about it is you ask an agent to do something, and you ask it nicely in a prompt. But it will run those harnesses that are long running agents. They can run for hours, right? I'm starting now. It will be over tomorrow morning. by tomorrow morning, after all the iterations and after all the compactions that it did, it doesn't remember things. It doesn't remember the whole instructions. It doesn't remember the whole prompt, and it's not necessarily following this thing. So what do we do? Who here is leveraging hooks instead of Claude Code? Awesome, right? So those hooks are kind of funny. So some of them are advisory hooks, right? If you do a hook on ethical right, and this is what I did, it's actually kind of an advisory hook. So here's an example, right? I gave it a goal. It was thinking, reading stuff, trying to figure out what it should do. Eventually, it said, "Okay, good. This is my plan. I will build this EC2 instance in AWS. It will have some stuff. I want to make sure it will be secured. I will put my checks here. I will put my test there. Let's start writing it." And now you see, it created a file, and here are my hooks. So this hook is actually TeraSky. I'm saying, make sure that 1, it's formattable. 2, it's valid according to the syntax. 3, the lint of Terraform is good. And 4, run Trivi to make sure that it's secured. So it's trying to do it, and it says, okay, it failed. But then it says, it's an advisory hook, so it's fine that it's failed. I will fix it later. Other things will fix it for me. So it continues to do it. Eventually, he gets to the point where he's able to figure out all the tests, all my hooks for format, validate, TF-lint, and tree, and he's successful. Who is familiar with the /goal of the Claude that they introduced, of the Claude code? Right. So /goal is pretty awesome. It's actually a hook that says, when you will try to stop the operation and quit, you can't until you satisfy the requirements of what I told you. And this hook is actually interesting because what I'm doing beyond this is I'm actually saying him, when you'll have everything working, make sure that you actually apply this Terraform and then test it. And you cannot wait until it's actually working. So he will be stuck in this loop of making sure that it's applied and then secured, and only then it will be able to quit. And this is kind of the very important thing here of how you know that the outcome is valid, deterministic according to what you said. But I actually want to show you this thing because I think it kind of relates to the previous conversation. AI agent given the task and even given the instruction, and especially given the hooks, after a while, models become kind of, they behave lazy, and they will try to trick themselves out of the solutions in a very unique way. So in this output, he realized that I'm forcing him to not to allow access to anywhere, to like 0, 0, 0, 0, 0. And what it does, it says, you know what? I see the rule, and this rule is preventing for me to open it to a whole world. So I'll just break it into 2 rules, half of the world and the other half of the world, and this way I won't be blocked, right? So you know this is not the behavior that you want, and it will be successful according to my current hooks. And that's the point that I'm saying, that you have to make sure that you look at the results and you go and you iterate, 1, over your guidelines or over like your prompt, that what you want to get, but 2, over your rules or over your deterministic sensors. Now, sometimes, by the way, when this thing is running, sometimes it does the other thing that is also very smart. It says, you know what? I cannot protect it with EC2. Let me take this very not known thing that called light cell and run this instead, because no security tools actually know how to handle it. And then it kind of tricks the system. So there are ways, for example, to enforce it. Like a good example is a policy scope, right? So now I can say, here's a policy scope for my Terraform, and I'm forcing it to be very specific. I want it to be only EC2s. I want it to be only like with that level of security or that level of code quality. So eventually you can see that I'm getting into the point. Just want to show you that it finishes here with everything and starts planning. And then it says, oh, I'm actually trying to plan, and I realize that I'm missing the whole VPC. I cannot deploy it. So when you're giving an agent an ability to actually try the code and execute and try to deploy it, then you actually realize the things that you cannot find otherwise just by creating a code that unit test. You actually need to deploy it and test it as a full blown solution. So you end up with fully functional, valid, secured, planned, applied, and tested code, which is kind of nice deterministic result. And again, you have to read through the output that you get, and you have to continue updating your harness, otherwise it won't work. And the way it's implemented is super straightforward. Right? And this is like a naive example, and again, it was just convenient enough to build it in the Cloud Code agent, but you can do it in Cloud Code. Here are my static tests, and here are my expensive tests. I don't want to run them every time because it's still not ready. And then I'm just have some function that are presenting how I want it to run. By the way, did you try working with Cloud Code SDK? Cloud Agent SDK? Good. So it really handles the loop very, very well, and I have a lot of ability, and I also get a lot of capabilities of Cloud Code. This is very, very convenient. At the end, I'm defining here what is my model, what is my system prompt, and my system prompt is referencing the guidelines. So the guidelines are my nice way to ask it to do things like be secure, be valid, be like quality. But then I also have my deterministic set of tools like my static code analysis and my expensive codes. And if you think about it, nobody canceled everything that we did in DevOps, right? It's the same thing. It's like my inner loop and my outer loop, and I don't have to do it in a CI/CD later. I can do it right now as part of my hooks. And basically that's kind of the code, and the guidelines are just explaining what I wanted to do. And by the way, you have to iterate through this thing because it will try to do extra work if you don't build it right. It will try to figure out, okay, so let me check how tests are working and let me try to trick the system instead of just trying to rely on hooks and on their feedback and try to adjust accordingly. Okay, so I hope that makes sense. What did we see? We saw the LLM, the harness that made my coding AI agent. There are guidelines that this is kind of my nice way to ask what my code should do or what my agent should do. There are sensors that will make the deterministic tests and will make sure that it's actually working properly. And this behaves exactly as we would do in the past, like inner loop, outer loop. The thing that I feel nobody is talking about is the distribution, right? So I have this code, it's fine when it's working on my laptop. I don't necessarily want it to work on my laptop. How do I run it remotely? How do I provide to this thing everything that I have to provide? And I probably don't want to do the remote agents of Anthropic because it costs a lot. So this connectivity of like distribution and even platform engineering and harness, I think is right now definitely missed by most of the industry. Obviously the cost, right? Did I actually create something that was worth all of those tokens, or could I do it better, or should I stop at some point and try to do it myself? Sandbox and security. One of the very important things is that coding agents are not great if you're not giving them bash. They cannot figure out a lot of stuff if they're not trying those stuff in reality to try and actually implement and try and iterate over it. But once you give it bash, it's super, super powerful. So you have to like secure it with runtime security, with sandboxing, because it can do a lot of stuff with, indirect prompt injection through some skill. It can be super, super malicious. So, to summarize, humans are imperfect, AI can be imperfect too. You should build the guidelines as part of your harness, and the validation, deterministic validation hooks that will make sure that they're not just advisory, but actually explicit and will force the agent to do whatever you want it to do. Accept, define, improve, and retry, so you will iterate over your harness. It will never be over. It's like DevOps or like everything else that we did before, no magic bullets here. And the harness itself, like there's a lot of conversation they're starting now about like the meta harness. How do I build and distribute and control my harness? Thanks a lot.
Woo!